This last section in chapter 1 is about rational expressions, and we're just going to start just with a little problem to show you how rational expressions can come up. You've got a pastry shop that has fixed cost of $280. Now, fixed costs are costs for rent, things that won't change no matter how much you sell in a given week. Okay. So fixed costs of $280 per week, and variable costs, so that depends on what you produce. So if you produce, you're going to sell chocolate here, so if you have to buy more cocoa to produce your chocolates, those are variable costs depending on how many boxes you sell. That's going to cost you more. So variable cost of $9 per box of chocolate. Find the cost per box. There's a word here missing. Find the average cost per box if X boxes are made. So before we find the average cost, let's just find the cost for producing X boxes. Okay. Well, what's the cost? Cost is, it's the fixed cost plus the variable cost. Now the variable cost depends on how many boxes you sell. So it's $9 per times the number of chocolate boxes you sell. So it's 280 plus 9x, that's going to be your cost. Okay, so example, okay, if the shop makes 100 boxes during that week, the cost is going to be, the fixed cost, because you can't do anything about that, and the cost is $9 per box. So that's 900, right? So 900 plus 280, that's 1,180, okay, dollars for producing those boxes of chocolates. Okay, so probably you want to sell them so that you earn more than that after selling those 100 boxes of chocolate, so that you make a profit. Okay. Now the average cost, okay, would be that amount, okay, for producing those 100 boxes of chocolate divided by how many you made. So divide by 100. So it would be $1.18 essentially per box, okay? So that would be your average cost, okay, for 100 boxes. Now, what is it if you sell X boxes? Well, you take your cost, so the average cost would be the cost for producing X boxes, which you divide by the number of boxes you made, by X. So what you end up with here is a ratio of polynomials. Okay, this is a simple commerce problem, and already we've got polynomials, and actually we've got a division of polynomials. So that's called so it's a ratio of polynomials, but another name for it is a rational function. So actually I meant a rational expression, okay? So, okay, we can simplify those, so we're going to start with that, simplifying rational expressions. Okay, how does that work? Okay, let me give you an example. Here's a polynomial that we divide by another polynomial. Okay. And the principle is kind of the same as simplifying something like 8 over 24. Okay. You want to find factors at the top and at the bottom that are common so that you can reduce the numbers. Okay, this would be actually 1/3. Right, so make it into a smaller fraction. We're going to do something similar here. By factoring this, we're going to see if they have common factors and rewrite this with this fraction of polynomials with polynomials of lower degree. That's our goal. Okay, so instead of having smaller numbers, we have polynomials of lower degree. So let's factor the top part. So x squared plus 8x plus 16 That's case 1, right? But it's actually even more than case 1. It's a perfect square. 16 is 4 squared, and the middle term is 2 times 4 times x. So this is actually a perfect squared at the top, x plus 4 squared. And the bottom, maybe first thing is to take out the greatest common factor. So we've got a greatest common factor of 2. And if you do this, what is that? That's 28 here, okay. And then we apply the, we want what? A product of 28, a sum of 11, you get them, 7 and 4. So this is x plus 4 squared, 2 times, and here since the coefficient of x squared is 1, as soon as we've got our numbers, 7 and 4, it's x plus the first number, x plus the second number. And now you see I've got a common factor of x plus 4 here. Don't forget that it's squared at the top. Okay, so I've got 2 copies at the top, 1 at the bottom. So I can, the idea here is that I can write this fraction as a product of 2 fractions. One is x plus 4 over x plus 4, and the other is x plus 4 over 2 times x plus 7. Okay, can split it up like that. And this part, this is 1. So if I multiply by 1, it's not going to change the other part. So I can sort of, so this is what people do, right? They say we're going to cross these out. So here they'll say, okay, I'm going to take away 1 power of x plus 4 and x plus 4 here. So I'm going to be left with x plus 4 at the top. So this is what people will do. But I want to show you why we can cross things out. We can only cross things out if they are multiples of the top and at the bottom. So again, we can write them as 1. Okay, one over the other, the same, this exact same factors. So that just becomes 1. So this is how this thing simplifies. Okay, we just have to be careful here. Here in this expression here, I clearly cannot divide by minus 4, right? I cannot divide by 0, and that occurs if x is minus 4, but it doesn't show here. It doesn't show here at all that I cannot replace x by minus 4. So one would actually say here that this is true if x is not equal to minus 4. Because if it is, this expression that we have in the end here, this is completely well defined at minus 4, where this one isn't. So that's the thing though, right? When you simplify these rational expressions, you're going to lose information. You're going to lose the values of x that cannot be replaced into the expression. Okay, now we're going to multiply and divide. Okay, our rational expressions. So let's say we start by multiplying. So this times this. Okay. So the principle is the same as if you do, this times this over this. So of course, what you can do is multiply the top part, okay, and you get 63, bottom part. Actually, you get 63 again. Okay, and then simplify. Okay. But you're going to deal with large numbers. So here I kind of lucky I got the same number twice, but you could have like different numbers and they're big and it's going to be hard to simplify. So the easiest thing is to factor or think about the factors of your numbers first and say, hey, I've got common factors at the top and at the bottom here. Okay. And this is way simpler now. It's 3 over 3, which is 1. So okay, so it's easier because I'm dealing in the end with smaller numbers. Okay, it's going to be the same with my rational expressions. I'm going to want to factor them first and see if they have common factors. Simplify those common factors and then do the multiplication in the end. So I'm going to factor x squared plus 4x minus 4. There's a coefficient of 1 that multiplying x squared, so I can apply to my shortcut. So product of, right, so I'm looking for a product of minus 5, sum of 4. Product minus 5 means 1 is negative, 1's positive. So 5 and minus 1, I think that's going to work, yes. So x plus 5, x minus 1 at the top. At the bottom, I can take away a 3. And here, 2x minus 1, there's nothing you can do when they, well, about that polynomial. They don't have, like, I cannot use the greatest common factor in either of them. So this is how it stays. But now I can see, oh, x plus 5 are common to both. So I just simplify those, and then I can perform my multiplication. I multiply what's at the top and what's at the bottom. And that's it. I could leave just my... Oh, I made a mistake. 3. This is a 6 here, because 3 times 6 is 18. And then I could... It's actually preferable to leave your answer factored, so you don't need to multiply anything in the end. You can if you want to, but it's usually we could just keep it factored like that. So that's multiplication. Division is like a division is a multiplication. So if you do this, right, 2/3 divided by 7/4, this is the same as 2/3 times 4 over 7. Okay, so dividing two polynomials is the same as multiplying them. Okay, so if I've got this, okay, so first of all, I'm going to write this as a multiplication. That's your first step. Okay, which is basically easy. You just flip this. Okay, and then we're going to factor them. Now maybe on the side here, I'm going to factor 2x squared plus x minus 6. Okay, so I need a product of minus 12 and a sum of 1. Oh, think about it. 4 minus 3, I think, is going to work. Yes. So 2x squared plus 4x minus 3x minus 6. You factor by grouping. So you're going to end up with 2x minus 3x plus 2. X squared plus 2x plus 1. Product of 1, sum of 2, 1 and 1. Oh, it's a perfect squared. Okay, this is the difference of squares. X squared minus 1, that's x minus 1, x plus 1. Difference of squares. X squared minus 4, that's also a difference of squares. Okay, perfect. Everything's factored. Now let's see if I can identify common factors. X plus 2, x plus 2. All right, so this is like multiplying by 1. X plus 1, there's one factor of x plus 1 that goes away, and that's it. So I'm going to be left with 2x minus 3 times x plus 1 over x minus 1, x minus 2. That's division. Addition is a bit harder. Addition, subtraction. Let's say I have this. Okay, so to add fractions, you need to have common denominators. So this is the thing I need to look for. So what are the common denominators? And to find common denominators, we need to factor the denominators to see what the factors are, right? So if I have, it's the same idea with fractions, if you with numbers actually. If you've got this minus 2 over 18, you need to know the factors of each number here. This is 3 times 3. This is 3 times 3 times 2. So I can see that maybe that's not the best example. Let's say write 36 instead. No, 30. No, not even. Write 27. So 3 times 3 times 3. So what would be a common factor of 27 and 8? I can just look at the yeah, you can just look at the factors of each, right? So I need one copy of 3, another copy of 3, another copy of 3. Here, I already have, if I include 3 copies of 3, it's going to fit into a number that has 2 copies of 3, and I need this one copy of 2. So that all numbers here now fit. So these two numbers, they fit into this one, right? 3 times 3 times 3 fits into 3 times 3 times 2, and 3 times 3 times 2 fits into 3 times 3 times 3 times 2, because all the factors are found in them, and that's actually the smallest number that in which you could fit both denominators. I hope that's clearer than what I said previously. Okay, so and then you'd use 3 times 3 times 3, so 27 times 2. You'd use 54 as your common denominator. Okay, so that would 54 would be what we call the least common denominator, the smallest one. Okay, and then you to get a 54 here, you need to multiply this guy by 2, this guy by 2, because that's the missing factor that you don't have here, right? You don't have a 2 times 2 here, so you get 6, and then here 18 you need to multiply by 3. So it would be 30 it'd be hang on, this is 2 times you need to multiply by 3, right? So you need to multiply this guy by 3 here, so you get get 6 here. Yeah, that's because I'm being stupid. I could have simplified my fractions before. Anyway, my point was to show you the LCD, but you basically get 0 here. But I could have seen that immediately, right? So this is 1/3, 1/6, and this is 1/6. So I'm doing 1/6 minus 1/6. That's why I get 0. But anyway, it's going to be the same principle over here. We're going to factor our. So maybe let's write it here. I'm going to factor my denominators. This is actually a perfect squared if you think about it. This is x plus 2 squared, and this is a difference of squared, so it's x plus 2 times x minus 2. So what's the LCD here? LCD, I need 2 factors clearly of x plus 2. Okay, and I need 1 factor of x minus 2. Okay. What you don't want to do is multiply them together. If you multiply them together, you're going to get x plus 2 cubed times x minus 2. And that would be an overkill. You don't need to have a cube there. A square is fine. That's all you need. Okay. So I need to multiply the top part by x minus 2. So that everything stays equal. Then the top part here needs to be multiplied by x plus 2. So now I have equal denominators, right? Same denominators, so now I can add the numerators. So it's going to be 6x minus 2 minus x plus 2 over x plus 2 squared x minus 2. And now I can expand the numerator and group like terms. So 6x, that's 5x minus 14. Feel like I've done something wrong somewhere. Let me check. Okay, I got it. Just forgot that 2 here. So somehow it got changed to a 1. So let me correct this. 2, 2. And then we get 2x minus 4. Okay. And so finally we get 6 minus 2 is 4x minus 12 minus 4 minus 16 over x plus 2 squared x minus 2. And in the end you factor, because your hope is that you can maybe simplify things in the end, but here it's not the case. I don't have common factors at the top and at the bottom, but nevertheless it's better to have a factored answer than an unfactored one. So that's our final answer.